Welcome to another video. The topic of this video is going to be bootstrapping. Okay, what's bootstrapping? Bootstrapping is a process that allows us to get a good feel that is an accurate assessment to what a specific spot rate should be in the event that there's some perceived illiquidity along certain or at certain maturity segments of the yield curve. So for example, if you think that a 17-period spot rate, okay, is inappropriate, perhaps it's exhibiting very wide bid-ask spreads. For example, a 17-period maturity treasury strip, okay? And you don't have a lot of faith in that 17-period number because the bid-ask quotes are wide and there's a lot of room for what it might be in there, etc. One way of getting to an accurate assessment of what the appropriate spot rate is for 17 periods, what we would call S sub 17, or what I've called in some of my videos here. Bootstrapping is the technique you'd use. Now, we're not going to go out to 17. We'll start something shorter because you'll see it's a lot of algebra, but you'll get the point, okay? So let's say we have a zero coupon yield curve where the 1 period spot rate is S1. S1 equals the 1 period spot rate. And there exists also S2, 2-period spot rate. And we don't really trust, our question is, what is the appropriate value for S3? Okay, so S2, it's the 2-period spot rate. We trust that. But we're not sure about S3. Maybe it's wide bid-ask spread, etc., etc. So here's one thing you can do. Well, we need for there to exist a 3-period coupon bond, in this case, Treasury security. Okay, a 3-period coupon bond. And let's say that one does exist, maturity equals 3 periods. And let's just assume the coupon rate is 4% per period. Okay, so, the world might pay, the bond might pay interest every 6 months. So the world would call this an 8% coupon rate, but we do things more precise here. It's 4% per period. And therefore, the promised cash flow stream of this 3-period coupon bond is as follows: 40, 40, and then 1,040. It's the promised cash flow stream. Okay? Well, let's assume that this is a liquid market. That is the market for this 3-period maturity coupon bond. Assume it's a liquid market. And so we trust its price. And then I'm going to show you how you get S3. Okay, the 3-period spot rate, which we had said we were uncertain of its value. So here's what you do. So there is some known price, some number, okay? That indicates number, but a known number. So number, some price, is equal to, 40 divided by 1 plus the 1-period spot rate, plus this 40 divided by 1 plus the 2-period spot rate square, plus 1040 divided by 1 plus the 3-period spot rate cubed. Okay? Standard bond pricing. And so our question is, hey, what is the 3-period spot rate? So if we trust this number, because we think this is a liquid market, narrow bid-ask spreads are one indication of a liquid market. If we trust that number, then as long as we know S1 and S2, then we can get S3. Okay? So, for example, let's just assume this number is $950. Okay? So 950, and let's just assume S1, yeah, I'll put a value in for S1. 40 divided by 1.05, that's 1 plus, this implies S1 is 5%, plus 40 divided by, let's say, 1.055 square. So here I'm assuming that S2 is 5.5%, right? And plus 1040 divided by 1 plus S3, S sub 3, the 3-period spot rate, cubed. All right, well, by now it's trivial, obvious to you, that we can kind of rearrange things here. And when we rearrange things algebraically, we're going to, because we have one equation with one unknown, the only unknown is S3. And because we have one equation and one unknown, we can algebraically manipulate this to get a value for S3. S3 equals some number, okay? So that just shows us how we can use this bootstrapping procedure to get a spot rate. Well, I guess bootstrapping implies you can do it again. So because we found the 3-period spot rate, we could then find a 4-period spot rate, and so on. Okay? For example, if there exists a coupon bond, treasury bond, I'm assuming these are treasury bonds, coupon bond with a maturity of 4 periods. Let's say it has a coupon rate of $50. Okay? And then if that exists, then, and let's just say that, we're concerned, we don't know what the appropriate value for the 4-period spot rate is. Okay? We don't know what it is. We don't trust it. Wide bid-ask spreads for 4-period maturity treasury strips, whatever. The idea is we can take advantage of our knowledge of S3 that we just got in combination with our knowledge of S1 and S2, okay, such that we can get S4. And so, again, the promised cash flow stream for the 4-period maturity bond is 50, 50, 50, and 1050. And again, we trust this bond. We assume this is liquid. A liquid market is the type of market the bond trades in. So we trust its price. So there's some price for this bond. Okay, there it is. And we know that because it's a risk-free bond, its price will be equal to the present values of all the expected future cash flows, all the promised cash flows from the bond, discounted at the appropriate spot rate, as explained in other videos. So this equals, if this is the price, a known market price, known and trusted for being determined in a liquid market price, that number right there is going to then be equal to 50 divided by 1.05, that's S1, plus 50 divided by 1.055 squared, that's S2, plus 50 divided by 1 plus S3 cubed, and don't forget, try not to get bogged down in arithmetic calculations here, so we can stay focused on what really matters. That S3 is a known number, or a known value. Okay? In other words, it's not a variable. But then, so this price then is equal to these plus, of course, this last cash flow. Go back to green for this. Plus 1,050 divided by 1 plus the 4-period spot rate to the 4th power. Okay? Well, again, obvious, trivial. This then is the only variable, the only unknown in the equation, and therefore we can algebraically manipulate this equation to eventually be able to say S4 equals some number. Okay? And so now we've just solved for S4, and we can continue with this process to get, if we need, S5 and S6 and S7, and so on. And that is bootstrapping. Bootstrapping the zero coupon yield curve. Bootstrapping the zero coupon yield curve. That's all. Thanks for watching.